Hey everyone, we're going to continue our discussion of vectors. Today we're going to talk about how we can use vectors to solve different types of application problems. A couple of things though we need to go through first. First of all, let's talk about writing a vector in terms of its magnitude and direction. And I'm going to explain where this equation comes from. So if you have your coordinate axes, right, and here's your point AB, right, then my vector v would be ai plus bj, correct? And then this distance we would signify this way. So that would be the distance of that, right? And I could draw this in, and this would be a, and this distance would be b. And let's call the angle here, let's call that theta. And so now this should be kind of familiar to you when we talk about the cosine of theta and the sine of theta. So the cosine of theta is going to be a over the magnitude of v. And if I cross multiply, right, I end up with a is equal to v cosine theta. And let me do the same thing for b, right? So if I do sine of theta, would be opposite over hypotenuse. And then if I cross multiply it, I end up with b is equal to v sine of theta. And so if you go back to what we talked about before, that the vector v is just ai plus bj, and I substitute in for a and I substitute in for b, that's where this comes from. Okay? So basically what we are talking about is this idea of a direction angle. That's where that theta comes in, because now we can apply direction with that magnitude. Okay? And when we talk about a vector that represents not only the direction but also the magnitude, especially if we're talking about speed, we refer to that as a velocity vector. And we'll do a couple of example problems with that. So let's look at the first example. It says the wind is blowing 20 miles per hour in the direction north, 30 degrees west. We know how to do that angle, right? Because we talked about bearings before. So if I were to draw that, here's my north-south line and then my east-west line. I'm north 30 degrees west, right? So this angle here is 30 degrees. But remember that theta is going to be all the way from the x-axis to that. And so that would be my theta. And so then my theta is going to be that 90 degrees plus the 30. So my theta is actually 120 degrees. Now I know the magnitude because it gave me that. It told me that that's 20 miles per hour. But what I'm trying to do is find the velocity vector. So I know that my theta is 120. I know that my magnitude is 20. And so I can just simply plug into my formula the magnitude of v cosine theta I plus the magnitude of v sine theta j. So I plug that in. I have 20 times the cosine of 120 I plus 20 times the sine of 120 j. Cosine of 120 is negative 1/2, so I have 20 times negative 1/2 I. Sine of 120 is √3/2. And then if I simplify that, I end up with negative 10 I plus 10 √3 j. And that's the velocity vector for this given situation. So it's pretty straightforward. You're just really plugging in and solving from there. Okay? Let's try another one. This case we have the jet stream is blowing at 60 miles per hour in the direction north, 45 degrees east. So north 45 degrees east would put me here. So this angle is 45. But remember, theta comes from here. So I know that theta is also going to be 45. And then I know that my velocity is 60. So if you want to go ahead and pause it, try to figure it out yourself. You can pause the video and then start it back up again, and I'll show you the answer. Okay, so if we write it out here, I've got V is equal to 60 cosine 45I plus 60 sine 45J. That would be 60 root 2 over 2I plus 60 root 2 over, over 2. Let me fix that. J, and then that would give me 30 root 2 I plus 30 root 2 J. Okay, so those problems are pretty straightforward. The last two problems are talking about resultant force, and we did this when we were first doing application problems with law of sines and law of cosines. But here we're going to use that whole idea of bearings, and now with this new formula that we have. So it's a different way of approaching it. Okay, so we've got two forces, F1 and F2, of magnitude 10 and 30 pounds respectively, acting on an object. The direction of F1 is north 20 degrees east. So my first one here, let me do this in a different color. Let's do brown here. So this here, my first vector, I know has a magnitude of 10. So that's going to be 10, and I know that this angle is 20 degrees, north 20 degrees east. F2 is going to be north 65 degrees east, and that's going to be 30, right? The magnitude of that one is 30, and this angle here is 65. Okay, so if I go ahead and look at F1 first, F1 is going to be F1 cosine theta I plus the magnitude of F1 times sine of theta I. Okay? So if I go ahead and plug my values in, I end up with 10 cosine. Now remember, this angle was 20 degrees, so my actual theta is going to be 70. So this is 10 cosine 70I plus 10 sine of 70I. So that's my F1. And then I'm going to do the same thing for F2 to get my velocity vector. And for F2, I have 30 cosine of 15 plus 30 sine of 15. So those are my two vectors, right? My two velocity vectors. It says find the magnitude and the direction of the resultant. Okay, so for the resultant, all I'm going to do is I'm going to add my two vectors, my two forces together. I've already dealt with my angles and everything like that, so I'm just going to add them together. So when I add them, right, I'm doing, let me change color here. I've got my resultant vector is going to be F1 plus F2. Okay, so if I add those together, I'm doing 10 cosine 70I plus 10 sine 70I plus 30 cosine, I forgot my I and my J here. Oh, that was supposed to be a j. Cosine 15i plus 30 sine 15j. Okay, so now I can combine my I terms, and then I can combine, that's supposed to be a j, and combine my j terms. Okay, so what I can do is this, 10 cosine 70 plus 30 cosine 15. Those are both my I terms. So all I'm doing, and I know I didn't show the step, I'm just combining my like terms, but I can't just add them because they're different. So all I did was factored I out of my two terms with I in it, and then I'm adding those together, and then I'm going to factor j out of my two terms with j in it and add those together. So then I have 10 sine of 70 plus 30 sine of 15 j. And so this right here, this calculation you can do in your calculator. You can just put it in exactly as it's written. Just make sure your calculator is in degrees. So 30.61i plus 22.08j. And once you have that, then you can find what you need to. The magnitude and direction of the resultant force. This is the resultant force right here. Now I have to find the magnitude of it. Okay, so now I'm going to have to to find that, I'm going to have to do the square root of 30.61 squared plus 22.08 squared. Do that in your calculator and it comes out to 37.7. Okay, 30.7 pounds. And then the angle, remember, I'll write it up here. Remember the tangent of theta, because I'm trying to find the angle, is just b over a. Well, I know what my b is and I know what my a is. I have that right here. It's just 22.08 over 30.61. And if you were to put that in your calculator for theta, you get 35.8 degrees. And you do not have to give that answer as a direction because it's already a direction angle. So I know that that's starting at 0 and going in the positive direction. So I don't need to write it as a bearing. I can just write it as the angle. Okay, so that's how you would go about doing that. I'm actually going to just give you the answer to the last problem. I'm not going to work through it just because I'm kind of out of time here, but you would set it up the same way. Okay, I'll set it up for you. So F1 is going to be 30 cosine 80i plus 30 sine 80j. F2 is going to be 60 cosine 30i plus 60 sine 30j. If you go ahead and follow the other model there, when you solve for F, you end up with 82.54 pounds. And you end up with theta is equal to 46.2 degrees. Okay, again, it's the exact same way as you did the other one. Combine your, to get F, you're just going to combine your I's and combine your J's. And for F, you would get 57.17 I plus 59.54 J. And I'm going to leave it up to you to make sure that you get the same answer there for that. But that's how you would go about doing it. Okay, hopefully that'll help. Hopefully I will see you guys tomorrow in class. I'll let you know if for some reason I have to cancel. Otherwise, I'll see you next time. Thanks, everybody. Bye-bye.